Welcome to this session. So far we have looked at basic concepts and testing, and then later we looked at unit testing, both black box and white box testing, and the main objective there was to remove the faults as much as possible from a unit, and we said that the definition of a unit varies. It can be a function or a module, and once a unit, all the units have been fully tested, we do the integration testing, and the main motivation behind integration testing is to remove the faults at the interfaces of various units. And after the integration testing is over, the system testing is taken up, where the full system is tested as a whole, and here the testing is done against the SRS document. So far, both unit and integration testing, it is tested as per the design document, whether the unit and integration testing are all right, and therefore, the unit and integration testing are known as verification techniques, whereas the system testing, where the final software that is to be delivered to the customer is tested against the SRS document, is known as system testing. Now, let us see what is involved in system testing. Actually, we had said so far in the last session that there are three types of system testing depending on who carries out the testing. If it is done at the customer site, then it is called as alpha testing. Sorry, if it is done by the developer side, it is known as the alpha testing. If it is done at by some friendly customers, it is known as beta testing, and if it is done by the customer himself or herself, it is known as the acceptance testing. So, in all the system testing, there are basically two types of tests that are carried out. The functionality is tested as specified in the SRS document, and the functionality is tested as black box testing, because these are the specification of the functions, and we know how to design black box tests for a function. We had discussed several techniques for black box testing, and all these techniques are applicable here for the functionality testing of a system. The other category of testing, which has so far not been tested neither in unit or integration testing, are the performance tests. The performance tests are designed to test the non-functional requirements of the system as documented in the SRS document. So, let us see what are the different categories of performance tests that are done. The black box functional testing we have discussed so far in quite a bit of depth, and we do not have to really discuss separately how the black box test cases are to be designed for system testing, because the same concepts are applicable here. Let us look here about the system test, about the performance tests involved in system testing. There are a variety of performance tests that can be carried out on a system, but not all of them need to be carried out. It depends on what is the non-functional requirements specified for the software. So, we look at the non-functional requirements, and based on what is specified for the system, we have to carry out some or all of these various performance tests. Stress tests, stress test. The stress test is also called as endurance testing. Here we give abnormal inputs to stress the capability of the software. By abnormal input, we mean beyond what is specified in the SRS document. Let me repeat that, because this is a very important statement. In stress testing, we give input to the software that is beyond what is specified for the SRS document. For example, we might give more data volume, the size of the database for a software than what is specified. If it is specified 100,000 records, we might give 120,000 records. Input data rate. So, if the data rate that the software is required to handle is 100 kilobytes per second, we might test with 110 kilobytes per second, just to check is there any abnormal reaction by the system. If it slightly exceeds the specified data rate, does the system crash? Does it behave something very unacceptably? Because if we give input which is beyond what is specified, it is expected that the system will show a degraded performance, but that should be a gracefully degraded performance rather than a discontinuity of the performance like crash or hang and so on. The processing time, if the processing time is required to be of few millisecond, we might give slightly more than that. Utilization of the memory, etc. So, these are tested beyond the designed capability. Okay. So, stress testing is giving input which is beyond what is specified in the SRS document, just to check that the system gracefully degrades if we give input which is beyond the specified capability and there is no discontinuity such as crashes or system hangs and so on. So, stress testing usually involves an element of time or size. For example, the number of records to be transferred per unit time, maximum number of users active at any time. For example, a system may be designed to support 10 active users at any time. Now, during stress testing, we have to check that if there are 11 active users, does the system still function even though in a slightly degraded mode, or does it go into a crash or a hang? If it is performing with 11 users, when 10 is the specified number of users, in a slightly degraded mode, it passes its stress testing. Similarly, we check with slightly larger data size than what is specified, and as is must be clear that for many systems stress testing may not be applicable. Let us look at some examples of stress testing. Let us say we are testing an operating system which can handle a maximum of 15 multi-programmed jobs. So, in the stress testing we give, if there are more than 15 jobs that are initiated simultaneously, what is the response of the operating system. Similarly, a real time system, we might test the arrival of several high priority interrupts at the same time. If the system makes an assumption in the requirement document that any time only one high priority interrupt can come or two high priority interrupt can come, we do the stress testing by having slightly more number of higher priority interrupt coming at a time. Another type of system testing is load testing. In load testing, it is determined whether the performance of the system under different load conditions acceptable. So, there is a clear distinction between stress testing and load testing, in the sense that in stress testing we give input to the system which is beyond what is specified in the SRS document, whereas in a load testing we test the performance of the system at different specified loads. Just to give an example, if we have a web based application and it is specified that the system should at 100 hits per second, the response time should be less than 1 second. We test here at 90 hits per second, 100 hits per second. So, all within the specified range of inputs, and check is the system behaving as per its requirement. And there are several load testing tools. One open source tool which is very popular is the JMeter, which can be downloaded at the Apache jakarta.apache.org JMeter, which is used for load testing of web based applications. Another performance test is the volume test. In volume test, again the system is tested within the specified bounds as recorded in the SRS document. For example, let us say if the size of the data, that is queue size, is 100, does it handle when there are queue size of 99 or 100? Similarly, the size of arrays, stack, etc., are they large enough to handle the situations that are possible as mentioned in the SRS document? So, various sizes, for example, fields, records, file size, etc., these are stressed to check if they can accommodate all possible specified data volumes. So, this is important here, specified data volumes. So, volume testing, we do not test beyond what is specified data volume, we specify that we test whether the data volumes as specified in the SRS document, are they handled properly by the software. Another type of system test is the configuration testing. In configuration testing, which is applicable to software which are built to support various configurations. For example, we might have a minimal configuration for software where a single user can use it, or we can have a configuration where multiple users can use it, or we can have a configuration where it can use certain database, and so on. So, the objective of this testing, configuration testing, is that does the system work satisfactorily for the various specified configurations of the software. Another type of system testing is the compatibility testing. Here the tests are designed to test whether the software interfaces with other software and hardware as specified in the SRS document satisfactorily. For example, we might have a web based application and that is required to work with various web browsers. So, during compatibility testing, we check whether the software works with various web browsers such as Mozilla, Firefox, the Microsoft Explorer and so on. Another example of a compatibility testing is that if a system has to communicate with a large database system to retrieve information, we check various large databases that need to be supported, and then we check the speed and accuracy of retrieval. Another type of system test is the recovery test. So, in recovery test we check whether the software works well if some loss of power, data, device etc. occur. For example, we might be using a pen drive for certain software, and then suddenly somebody removed a pen drive. So, does the software hang, or does it say that please put back the pen drive for the software to work? Or let us say if the software is mentioned to tolerate power failure. So, when power failure occurs, does it lose all the data, or does it save the data before the power failure occurs? And then once the power is given back, does it the system recover those data properly? Another type of system test is the maintenance test. Every software needs various types of maintenance as it is used over a long time. For example, every software might have some diagnostic programs. If something does not work properly, the speed degrades or certain actions cannot be carried out, then the software typically need to provide default configurations where somebody can put the software into default configuration, and it can be checked whether it works properly in the default configuration. Diagnostic programs, traces of transactions, schematic diagrams about the connectivity to different modules, the way it needs to be connected to other software and hardware and so on. So, these are various maintenance testing kits, and whether these have been supplied and whether these function properly. One more type of system test is the documentation test. So, here in this type of test we just need to check whether all the provided documents are consistent and they have been provided, because the user when doing testing, acceptance testing, will also have to do the documentation test, where the user need to check whether the guides, user guide, maintenance guide, technical documents etc., they have been provided and are consistent. Sometimes for some software it may be required that they support various types of users. For example, very novice users, experienced users and so on, and whether the documents that have been provided for those category of users are as per requirement of those types of users. One more type of system testing is the usability testing. So, here the target is to test the user interface, various display screens, messages, report formats and so on, they are checked whether they are okay, and also navigation in the user interface, is it satisfactorily working, menu selections and so on, mouse clicks, are these properly recorded and handled. One more type of testing which is environmental test, which is not applicable to general software, possibly applicable to software that are required to work in devices which might work in different climatic conditions, for example, embedded systems. So, here it is checked whether the software which is maybe controlling a embedded device, does it work under different heat, humidity, chemical presence, portability conditions, electric, magnetic fields, disruption power, etc. Now, once all the tests have been done, the system tests. So, that is the test carried out either by the development team or a friendly set of teams which is the beta testing, or the customer himself which is the acceptance testing. The test observations are to be written down in a test summary report. So, what do we write in the test summary report? In the test summary report, we have to write the summary of all tests which has been applied to the test to the software. So, both functional testing and the performance testing, how many tests were applied, how many tests were successful, how many tests have been unsuccessful, and the degree to which they were unsuccessful. Was it that in the usability test, in some fields you have to click the mouse twice, so that is a minor problem, or is it that it crashed? So, whether the test was an outright failure or whether some minor unexpected results etc., were only observed. So, that should be the contents of the test summary report. Now, let us look at one problem which bothers every developer, every tester and every user of a software, that how many latent bugs are there in the software. So, the software, let us say a million line of code has been developed after a lot of work by the developers, it has been tested. Now, if somebody asks that what is the likely number of bugs or faults that are existing in the software after all these careful development and testing has been carried out, how do we give a number? How does the project manager determine that how many bugs are still there? So, one way to determine it is called as error seeding. So, how do we do the error seeding and how does it help us determine the number of bugs in the software? Here the main idea is that before the testing starts, the project manager or a senior person introduces some bugs artificially into the software. So, makes a few changes in the software which he keeps track of. He has recorded what type of bugs he has introduced. Maybe in some places he has flipped a arithmetic operator plus operator into a minus operator, or somewhere in the conditional statement might have made a less than equal to into a less than operator, or maybe somewhere where it is written a plus b plus c, he might have written only a plus b and deleted c, and so on. So, these are some of the bugs that the manager seeds, and then at the end of the testing he finds out how many of these seeded bugs have been discovered. If he seeded 100 bugs, out of the 100 bugs, how many of his seeded bugs could be discovered? And so, let us say these are the bugs which are existing in the software, and then the manager seeded some bugs in the software. So, the initial number of bugs which existed, let us say this is capital N, and now the manager seeded a set of bugs there, made arbitrary changes, and small and S is the seeded bugs. So, S number of bugs he seeded, and then the testing was carried out, and at the end of testing it was found that it has small s number of seeded bugs were discovered during testing, and small n number of bugs which existed, they have also been discovered by testing. So, these are the bugs which have been discovered, the seeded bugs and the unseeded bugs. Then we make a simple assumption that if small n out of existing number of bugs is detected, that must be equal to small s by s. So, we are claiming here or we are assuming here that the testing identifies the bugs in the same proportion to both the original bugs and the seeded bugs, and from this expression we get the remaining bugs n minus n is equal to n into s minus s by s. So, this gives us a very rough approximation of the number of bugs that are existing in the software. So, error seeding is an important technique to find out what is the number of bugs that has been left behind in the software even after doing a careful development and carrying out thorough testing. So, we will stop this session at this point and continue from this point onwards in the next session. Thank you.